The laser, a useful tool in industry, science, and medicine. But the laser is a double-edged sword. On one side, a beneficial tool. On the other, a dangerous instrument that can be harmful to those who use it. The beam of a ruby laser can burn through steel instantaneously. Some laser beams cannot be seen. The CO2 laser beam is not visible at any time. Only its effects can be seen. Normal clothing offers no protection from the laser beam. Almost any fabric will catch fire. Not only is the direct beam dangerous, but reflections also may be hazardous. An ordinary diamond ring will scatter reflections in many directions. This invisible hazard can cause much damage to the eye. Two kinds of reflected beams may be present in laser operation: specular and diffused. Specular beams are reflections from a lens. They can be thrown in any direction from the lens surface. Anyone in the area may come in contact with the reflections. Specular reflections, in turn, may reflect off of any number of objects in the area. Even turning the head may not be a protection. Diffused beams are reflections from the laser target area. Diffused reflections tend to spread the beam over a wider angle, often diminishing the intensity. In some instances, contrary to the obvious, the farther away one stands from the target, the greater will be the damage to the eye. Eye damage can be caused by very low energy levels. It takes only a small amount of the output of a 1-joule ruby laser to cause injury to the eye. Laser radiation falls within a very narrow portion of the electromagnetic spectrum. Various wavelengths cause damage to different parts of the eye. In the visible region, most of the radiation is focused by the lens onto the retina, the usual place of injury. The focusing effect increases the intensity of the radiation on the retina. For lasers operating in the infrared near the visible, the effects can be similar to those of the visible. Far infrared radiation, however, is absorbed by the cornea and conjunctiva. If the wavelength is shorter than that of the visible, it is ultraviolet and is absorbed by the cornea and the conjunctiva. At ultraviolet wavelengths closer to the visible region, because of the focusing characteristics of the eye, both the cornea and the lens may be injured. At ultraviolet wavelengths approaching the visible range, the radiation at the retina may be more intense than in the intervening tissues. Safety glasses should be worn at all times during... and the beam divergence, thereby calculating a safe distance. As part of NASA's Earth physics program, several satellites are being tracked by the laser ranging systems located at Goddard Space Flight Center and other facilities in the United States. Anyone in an aircraft intercepting this beam at close range could conceivably receive serious eye damage. To prevent this from happening, the lasers operate in conjunction with radar and visual observers.
This is radar. We have spotted a bird. Kill your laser.
Roger.
In order to provide a safeguard for low-flying aircraft, the laser operator works with a visual observer during tracking operations.
Aircraft coming. Kill the laser.
Roger.
The high voltages required for the operation of lasers present another safety hazard, the high voltage power supply. It is designed to be safe. When the power supply door is open, the safety interlock on the access door automatically shuts off the power supply. However, there still may be high voltage remaining, high voltage which can kill instantly. Because of this danger, maintenance should be performed by two individuals, since several manual operations may have to be handled simultaneously. To make certain it is safe to work inside, all high voltage points must be grounded and remain grounded. This will dissipate any stored charge remaining in the capacitor. This demonstration shows what may happen if it remains charged. Many of the materials normally used around laser operations are flammable, and specular reflections could set them afire. Cryogenic materials can be dangerous. This bottle of dry nitrogen should be strapped securely to a solid object. Should the bottle fall over and the regulator break off, the gases will propel the tank with extremely destructive force. Laser operation may result in the production of dangerous gases. In this demonstration, a synthetic object is struck with a laser beam, thereby releasing toxic gases. The laser laboratory should be ducted for the safe removal and disposal of various toxic gases. Any room in which a laser is operated should have certain basic safety features. The laser and its power supply should be positioned against a blank wall, so as not to block any escape route for the operator. Indicator lights on power supplies should be visible to the operator when wearing laser glasses. There should be an adequate beam stop. The laser system should be isolated from any other activity in the room with a safe partition, such as a blackout curtain or folding screen. All windows and door windows should have blackout curtains or some other absorbent material. Safety interlocks should be provided for all doors, the primary entrance and the secondary entrance, such as the isolating screen. The interlocks are connected to the power supply. When the power supply is turned on, the interlock switches lock the doors so that no one can enter during laser operation except in emergencies. The lock should not prevent quick exit from the room. Exhaust ducting should be installed over the target area to carry off toxic gases. The laser should be positioned well below normal eye level. Laser warning signs should be displayed prominently at all entry doors and near all laser operations. The laser can be a dangerous instrument. It can be harmful to those who use it, but to those who use it safely, it is a tool which can benefit mankind.